Here's another example to look at where I can explain it in class and take it for granted that everyone understands. But they don't necessarily, because we've got this problem in that what are we talking about? When we get a dot product, we know we have this rule. And the rule is, now by the way, that's multiply and that's multiply. So let's write it fussy for a moment. The dot product is the magnitude of A by the magnitude of B by the cos of the angle in between them. So these are not dot products. These are not dots. These are actual multiplies because that's a scalar. Once you get the length of the vector, it's no longer a vector, but it's a scalar. So you can write normal everyday multiply and normal everyday multiply. So you're just getting the cos of the angle. But this here, what does this have to do with this question? We've got a dot there. Now, by the way, if I knew what vector A was, I could make up anything. Let's say I said that vector A was 2, 3, and I said up here that they're not perpendicular. And say vector B was, let's go silly one, like 3, 4, because I know they're not perpendicular. So if I wanted to get 2A plus a B, so I get 2 of that, so that's 4, 3, plus B, which is 3, 4, then I've got 7, 7. So this is the vector, in that case would be just 7, 7. So what's going on with it? This is just a vector. Then if I had this one here, I could work out what that is as well. So we're multiplying a vector by a vector, because when I'm adding or subtracting vectors, they just become another vector. So let's have a look at what's going on. I know from, if you wanted to call expanding the brackets, you could talk about the first, outside, inside, last, and everything. Now I'm going to multiply the 2a, and listen to me saying the words, because I've said it for so many years. I'm going to get that dot product with that. We can talk about multiply, but there's two ways of multiplying vectors. There's that method and there's that method. Now we haven't learned that as yet, and this is called the cross product. And most people do a lot of the maths without dealing with the cross product till later on. We'll come back to that later. Actually in Western Australia it's more in 3 dimensions in year 12, but we'll have a look at what's going on here for a moment. So I've got this one related to that one. So I've got a 2a, it's a vector. So when I say times by 4a, it's actually the dot product we're going to use, not the cross product. So if I wrote multiply there, I'm actually mathematically being incorrect. So that's the first pair. The next pair will be 2a plus 2a dot product with minus 3b. Now I need to get rid of this. So that's that pair, that's that pair. This pair here is, now it's going to be B dot product with 4a, and then it's going to be the last one, B dot product with minus 3b. And I'm being more fussy than what I normally am, but I think you need to see it. So this is A8, A dot A. Now I can't write that as A squared. So A dot A is not A squared. Can't write it as that. But when I get the magnitude of A by the magnitude of A, then I can write it as a squared because it's no longer a vector. It's, for example, the magnitude of A can be called just A, and then it's the magnitude of A by the magnitude of A. So we've got, when we're getting the magnitude, we're no longer having vectors, but we're having scalars. And I can write that as A squared. But I can't write A dot A as A vector squared. Can't write it that way. So let's have a look at what we've got here then. So now I've got 2 3s of 6 for the negative, and I've got A dot B, and then I've got 4, and I've got B dot A, and then I've got, oops, then I've got minus 3 B dot B. Take our time for a second, it's getting too long-winded, but I think you need to see it slow. How do we get A dot A? We go back to the dot product formula. So I've got the A dot A is going to be the magnitude of A by the magnitude of A by the cos of theta. And what's interesting is I'm writing these as dots. Really in this case, because they're now scalars, I can write them as multiply. But the confusing part in maths, we can write multiplication as dot. So this is where it gets very confusing between the dot product and the cross product. So in basics, let's have a look at what this means. So the magnitude of A is just called A. So if I was talking about vector C and I wanted the magnitude of vector C, I'm allowed to just call it C. If I want the magnitude of vector D, I can just call it D. because it's no longer a vector, it's a scalar I'm nagging. So that's an a by an a, so I can write that as an a squared. And the cos of any vector, whatever it is I had before, 2 plus 3i, 2 plus 3i, what's the angle between them? And the angle between them is 0, and the cos of 0 is 1. So that just becomes a squared, not a vector squared, but a squared, scalar. Now I've got 6ab plus 4ba, and you go, well, what's the difference between an a dot b and a b dot a? So if I go back to here, the a dot b will be the magnitude of a times the magnitude of b, which is the same as if I write b dot a is the magnitude of b by the magnitude of a. So if my magnitudes turned out to be 3 and 4, of course it doesn't matter if you go 3 times 4 or 4 times 3. So that is irrelevant that they're the other way around. It's actually called the commutative law. So when I commute or change these around, they're the same as each other. So minus 6 of those plus 4 of those is minus 2. Now remember, I'm still writing vectors. So this is dot product. So we're simplifying this expression into that expression. This becomes not vectors, that stays vectors, and the last one by the same reasoning as we had before. So we've got minus 3, but the magnitude of b becomes b, scalar b. So we've got b squared. And that's the answer to the question. So all we're doing is saying, if I had a dot product with these vectors, not knowing what the vectors were, and they're not perpendicular, so they're not going to eliminate. By the way, if I did have them perpendicular, I can do the same question. But these parts here would become 0. So we'd still be left with the 8a squared minus 3b squared, but this part here would become 0. So we're just rearranging that expression into that expression. I hope it helps. Can get very long-winded, but I think you need it to get your head around what's going on. It actually made me stop and think about exactly what am I saying and what's accurate and what isn't. I hope you're enjoying it. If you do, just spread the word. Thanks.